Okay, so here we are going to start crystallization behavior of magma. Then I will say the phase rule. Okay, from phase diagram we are going to understand how from magmatic system the minerals got crystallized. Okay, and we will discuss different systems. Okay, so first of all, what is a phase diagram? What is a phase diagram? It is a temperature composition diagram. It is a graphical representation where in x-axis we are taking composition, in y-axis we are taking temperature. Okay, so this is for bicomponent. Then we will talk about three component. Well, I have not defined yet what is component, so just for the knowledge, just for your understanding, I am saying this is bicomponent. I will describe what is component later. Okay, so here what I have taken a graphical representation between composition and temperature. So what happens, I have already discussed when teaching you texture or something forms. Okay, so what happens when magma is at a higher temperature at the deeper surface, right? This is my earth surface. Let's say this is my surface. Magma chamber is somewhat here. Okay, it is having certain temperature Tm. What happens when it moves off, there is decrease of pressure, decrease of temperature. When it is at deeper surface, it is having high temperature and pressure. It is having high temperature and high pressure. Okay, at that point of time the magma is in liquid state. When it moves upward, that means the pressure is decreasing and the temperature is also decreasing. So what happens, according to Bowen's reaction series, we have already discussed Bowen's reaction series. What happens there? There are a set of minerals, right? In Bowen's reaction series, we are representing a set of minerals in the order of temperature. Let's say olivine, pyroxene, etc. Right? Discontinuous series and continuous series. Here it is plagioclase. Okay. Then here muscovite, quartz, etc. So Bowen's reaction series means we are representing different minerals on the basis of their temperature. So what happens in phase diagram, we will take either two components, that means two of the minerals or two of the elements. I will define what is component. Before that, just for introduction, we will take either two components or three components or one component. That means we assume that, or we are taking two of the elements from the entire magma. The entire magma, it is having many components, right? Magma is having many elements inside it, like potassium, aluminum, magnesium, calcium, etc. Right? It is having many components. Out of them, we are just considering two of the components. Then we are describing the relation between those two components, or we are just taking three components. We are describing the relation between those three components, how they behaves, how the composition behaves, or in response to temperature, in response to decrease in temperature. What happens to the composition in response to decrease in temperature? That we are representing in a graph which is known as your phase diagram, right? We are representing, let's say, I am talking about, okay, before that I will say phase rule, then I will go to elaborate this diagram, phase diagram. So let me write what is phase rule. So the phase rule is defined as, so I think all of you get this, that it is the relation between composition and temperature. We'll represent it in a graph. I'll describe it, just don't get confused. I'll describe. Before that, let me define what is phase rule. And one more thing I have forgotten. What this phase diagram will suggest? This phase diagram will suggest the crystallization behavior of the components which we are taking. Right? I have told you that the magma contains many components like potassium oxide, aluminum oxide, sodium oxide, etc. We are taking some components. We are taking either 2 or 3 or 1 component. We are representing in temperature composition diagram. Then we are analyzing the crystallization behavior. From that we can get which mineral is crystallizing earlier, how, in what proportion the mineral will crystallize, or the next thing we are going to study. Right? So what is phase rule? Phase rule is given as P plus F is equal to C plus 2. What is P? P is your phase. What do you mean by phase? Phase is nothing but this is the mechanically separable element. Mechanically separable elements. Okay? What does that mean? Let's say within magma chamber or in liquid form, in the magma chamber, in liquid form, there is potassium oxide, there is sodium oxide, there is calcium oxide also. Let's say, okay, in this all these are in liquid phase. All these are in liquid phase. Okay, all these are in liquid phase. So can you differentiate between sodium oxide and potassium oxide, or can you differentiate sodium oxide, potassium oxide and calcium oxide? Within a liquid you are getting sodium oxide, you are getting potassium oxide, you are getting calcium oxide. Can you differentiate between, can you remove that sodium oxide and remaining only K2O and CO? You cannot do that because all of them are in liquid state. They are mixed all together, right? So you cannot separate that. If sodium oxide will be a crystal, let's say there will be a sodic crystal or sodic mineral, this is in solid phase. If this is in solid phase, then you can separate it. This is a solid phase, you can separate it, right? If potassium, that is a crystal, you can also separate it, right? So now phase will become, before when all are in liquid phase, all are in liquid, then phase is 1. Okay, then phase is 1. Now what happens? There is sodium oxide as solid, sodium oxide, let's say sodic crystal, and then potassic crystal. Okay, all these are in solid phase, and then liquid. Okay, sodium is in solid form, potassium is in solid form, and rest of them are in liquid. In the liquid also there existing sodium plus potassium plus calcium, but you cannot separate all the three quantities, right? Because they are in liquid format. So they are considered as one phase. When they are in liquid, but when they become solid, you can identify which is sodium, you can identify which is potassium, right? So now there are three phases. Okay, one is the total liquid containing sodium, potassium and calcium. One is only potassium solid, one is only sodium solid. So there are three phases. Okay, then if calcium oxide is going to start precipitating, or calcium oxide start forming, then what happens? Calcium oxide plus sodium oxide plus potassium oxide, all these are solid, right? Solid plus liquid. Again, this liquid is containing all the three components, but it should be considered as one phase. 2, 3 and 4. Because you can differentiate between calcium oxide crystal and calcic crystal and sodic crystal. You can differentiate them when they are in solid phase, but when they are in liquid phase, you cannot separate. Okay? So now the phase becomes 4. So I think all of you get this. What is the meaning of phase? Phase means This can be mechanically separable elements. Then what is C? I will come to F. Then what is C? C is component. Right? Now you say me how many components are there? Sodium oxide, potassium oxide and calcium oxide. 3 components are there within this magma, within this melt. So number of component is 3. Okay. If I will consider that, as I have told you, that in a magma there are many number of components. While we are studying binary and ternary, that doesn't mean, binary means bicomponent, ternary means 3 component. That doesn't mean the magma contains only 2 components. That doesn't mean the magma only contains two components. But we are considering 2 components out of the magmatic system, and we are analyzing the crystallization behavior among those 2 components. Okay. So let's say I am considering K2O and SiO2. Okay, in this melt there is potassium oxide and silica. So the number of component will be 2. Right? If I am considering sodium oxide, potassium oxide and silica inside the melt, all are in liquid phase. I am not talking about phase now. Okay, I am only talking about component. So how many components are there? Sodium, potassium and silica. Right? So component is 3. If I am considering sodium oxide, potassium oxide, calcium oxide, silica, then how many components are there? 4 components are there. Okay. So like how many elements are there, how many chemical elements are there, or you can say these are the components, these are different components. Okay. Again, the component and the phase, they are not similar terms, right? They are different terms. Phase means you can separate them. Component means even if this system is in liquid phase, you can say the phase is 1, but the components are 4. Okay, the components are 4, but phase is 1 if all this is in liquid format. If all of them are in liquid format, you cannot separate each element, you cannot separate each components. That's why there are 4 component, but phase is 1. Here, if all these are in liquid phase, you can say 2 component and phase is 1. If SiO2 start precipitation, if SiO2 start precipitating or SiO2 becomes solid, okay, then what happens? Component will be 2, phase will be 2. Okay, if SiO2 becomes solid, K2O becomes solid, or K2O start getting solidified, SiO2 start getting solidified, and rest liquid also, there is K2O plus SiO2. So now component is same, K2O and SiO2 they become 2, component is same, but phase become 3. Phase become 3, K2O is 1 phase, K2O solid is 1 phase, SiO2 solid is 1 phase, and the liquid, entire liquid, that will be 1 phase, right? I hope all of you got this, that when they are mechanically separable, then we are naming it as phase. But if they are in the magmatic system, the components or the elements, we are naming it as component. The component is not similar with the phase. Okay? And on the basis of component, we are considering, as I have told, the magma is having so many elements, but we are considering either 2 or 3. So if we are considering for 2 elements or 2 components, we are naming it bicomponent. If we are considering only 1 element, we are naming it unicomponent system. If we are considering 3 components, then tricomponent. And accordingly, we are studying the phase rule. So unicomponent system, bicomponent or binary system, then tri-component or ternary system. Okay, as I have told you, we are considering only two of the components in the magmatic system, and we are studying the crystallization behavior. We are studying three components and studying the crystallization behavior, then tri-component. Okay, then the next term is F. What is F? F is degree of freedom. Is degree of freedom. So what do you mean by degree of freedom? Degree of freedom means whenever we are doing this phase diagram, in that phase diagram we are representing the magma motion, the direction of motion of the liquid. So this degree of freedom determines the path or the number of path in which the liquid can move. Okay. Okay, so degree of freedom means it determines the number of paths in which the liquid can move in a phase diagram. Okay, I have told you phase diagram is nothing but that is a graphical representation, right? You should not get that the magma is moving. Okay, we are just presenting the magma movement, means composition and temperature, that point in the graph. Okay, I will show you how we are moving or how we are using this formula. So I think all of you get this. Phase means mechanically separable element, F means degree of freedom or the number of paths in which the liquid can migrate. C means component means the number of elements we are considering within the magmatic system, either that will be unicomponent or bicomponent or tri-component. Then come to this 2. This 2 is used for two variables. This 2 is used for two variables. What are those variables? Temperature and pressure. Okay. When we are taking two variables, temperature and pressure, that means if we are considering for metamorphic system, that means the rock is placed somewhere at certain temperature pressure condition, then it is the mineral assemblage that is going to change due to modification of this temperature and pressure. So there are two variables, temperature and pressure. When there are two variables, we are using 2 here. But in igneous system, what we will do? In igneous system, we take that the pressure is constant. We are considering pressure is constant for igneous. For magmatic system, for igneous system, we are considering that the pressure is constant. That means, as I have told you, that if this is the magma chamber, it is somewhat here below the surface. And here it is the magma chamber, and I have told that the magma is moving upward. The magma is moving upward means there is decrease in temperature, there is decrease in pressure. Okay, so there are two variables. So what happens? We take that the magma is not moving. It is constant at certain point. It is constant at the magma chamber. It is moving. Suppose the magma chamber is here, or the magmatic body is here, right? The pressure is not changing means the magma is there itself. It is not moving upward. The place or the depth of emplacement of the magmatic body is constant. Okay, only there is change in temperature. That means the magmatic body rests in some place at depth, and only the temperature is decreasing, and it is not migrating upward, means the pressure is not changing. Then we are putting here 1 instead of 2. Instead of P plus F is equal to C plus 2, we are using P plus F is equal to C plus 1. What we are using? P plus F is equal to C plus 1 in case of magmatic processes. Okay, in case of magmatic processes, we are using P plus F is equal to C plus 1. Why? Because pressure is constant. Pressure constant means the depth of emplacement is constant. It is not changing. The magma is not moving upward. We are considering this. Okay, hypothetical. We are considering that magma is not moving upward. It is constant at some level and only temperature is decreasing. So with one variable, we are using 1 here. If we are considering metamorphic system, then we will use 2, because in metamorphic we are using temperature and pressure both as variable. Okay, so I think all of you get clear about this phase rule. Then I will start different component system, that is unicomponent, bicomponent and tricomponent. So I'll say some example of unicomponent so that you can better understand. Unicomponent. For unicomponent, we are using the best example is H2O. The component number of component is 1. In the system, the number of component, let's say this is the system, the number of component is 1, that is hydrogen and oxygen, right? Hydrogen dioxide. Number of component is 1, but the number of phases I can use like ice, water and gas or vapor. Ice, water and vapor. You can see ice, water and vapor. Ice is at lower temperature. As temperature is increasing, it turns to water and then turns to vapor. So you can see the phase you can separate. You can separate ice from water. Okay, you can separate water from vapor because these are separable. But this H2O, ice is having also composition H2O, water is also having composition H2O, vapor is also having composition H2O. So the number of component is 1, but the phases are 3. Okay. Similarly, one more example is there: kyanite, andalusite and sillimanite. Okay, kyanite, andalusite and sillimanite. What is the formula for this? Potassium and aluminium, potassium, aluminium and K2O plus L2O, L2O3 plus SiO2, potassium aluminium silicate, right? Potassium aluminium silicate. So this kyanite, andalusite and sillimanite, they are having same composition, potassium aluminium silicate, but they are different polymorphs. They are different polymorphs. Kyanite is occurring at high pressure. It is, yes, here we are considering both temperature and pressure. Here we are considering both temperature and pressure because we are using this example kyanite, andalusite and sillimanite in metamorphism. I think all of you noticed in metamorphic phase diagram. In metamorphic phase diagram, it will be like this. right? In metamorphic phases, there is some indication like this, and it is written here. Here it is. I think here it is silmanite, and here it is canite and andesite. I think I am wrong. This is andesite. I cannot remember that, but still, one person is canite, this one is andesite, na? I think this one is andesite, or andesite is not high temperature. Well, I cannot remember that, but still, canite is high pressure, and silmanite is high temperature. Yes, silmanite should be there. I think so. Cannot remember, but still, canite is at higher pressure, andesite is just let me check what andesite here, silmanite. Okay, I am doing it wrong. So here it's kyanite, this is silmanite, and this is andesite. Okay, so andesite is only high temperature, low pressure. High temperature, here it is temperature, here it is pressure, right? So andesite is having high temperature but low pressure, kyanite is having high pressure but low temperature, and silmanite is having high temperature and high pressure. Okay, andesite is high temperature but low pressure. You can see pressure is low. In case of kyanite, pressure is increased but temperature is low. In case of silmanite, temperature is higher, pressure is higher. Okay, so these are polymorphs. Okay, polymorph means same type of composition as I have told. Potassium, aluminum silicate, same composition but different phases, right? So here this is also a unicomponent system. Where the composition is same but number of phases are different. Here if we use the phase rule, this is P plus F is equal to C plus 2. P plus F is equal to C plus 2. Why 2? Because both temperature and pressure, these are variable. Okay, so we are using P plus F is equal to C plus 2. So I think this much is sufficient for unicomponent. We are not going to study the behavior. We will study it in metamorphism, not in igneous. Then let's move to bicomponent. Okay, so we'll start bicomponent. In case of bicomponent phase diagram or phase rule, we'll study phase rule. In case of bicomponent system, there are many type of system. We can divide this bicomponent into 4 systems. Like one is eutectic system of crystallization. These are on the basis of their crystallization behavior, right? This eutectic system or solid solution. Next is solid solution. Next is peritectic system. and next one is your what